Hello out there friends, and welcome to this video today in our YouTube channel. In today's video we shall be looking at how we can evaluate this our indefinite integral, that is the integral of sec cube x dx. This is an integral that most of my subscribers have been reaching out to me via email, via WhatsApp. They want me to show them how we can get this integral. Okay guys, please, just for a quick reminder, if you're new to our channel, please I highly encourage you to please subscribe to the channel and press the notification icon such that each time we upload videos you will be the first person to be notified. And guys, please don't forget to give this video a like. Just press the like button beneath the video, because by so doing it's going to motivate me enough to produce more great content for you. Thank you very much indeed, and I'm going to keep doing that for you guys. So let's get started. Let's dive straight into it. Okay, now guys, to evaluate this indefinite integral, guys, it looks so difficult because we are just integrating just one thing, right? Just sec cube x, and we don't have a direct solution for this guy. So now, and guys, keep in mind that in integrals sometimes the more things you have to work with is actually better. So we are going to see if we can split this integral as the integral of sec cube x equal to the integral of, we can split the sec cube x as sec squared x times sec x dx. Good. So now by so doing, guys, we can see that we have the integral of two functions now, sec squared x, sec x dx. Good. So now in this case, guys, we are going to use integrations by part. Why am I doing so? Why are we using integration by part? It is because we can differentiate one part of this function and integrate the other part. Each time you have a product of two functions, wherefore you can integrate one part and differentiate the other part conveniently. Just give integrations by part a chance, okay, and you hope for the best. But that is not going to work in all cases. It won't work in all cases. There are some cases where it will not work, others are going to work conveniently, but in this case this is the way in which we are going to go. So guys, we are going to use the DI method. We are going to use the DI method. And guys, keep in mind that the DI method, like I said in my previous video, if you've not watched it, go and check it out, guys. It is a summary of the integrations by part method. It is a summary that tries to summarize all what the integration by part has set up. Okay, good. So we are going to have our D and we have the I. D stands for differentiation, I stands for integration. So we are going to differentiate one part and integrate the other part. So the most difficult part now is to choose which part will you differentiate and which part will you integrate. But guys, the signs alternate from positive, then you have negative. So you must start with positive, the next becomes negative. If you need more rows, you still have positive, negative, and so on in that same pattern. Good. So guys, which part of this function do you think we should integrate? Which part should we differentiate? What do you think, guys? Please just pause the video and think for a second, then you unpause it now to check the solution. Okay, hopefully you've done that right. So now guys, you see that keep in mind that to integrate sec x, at least I did that in my previous video. So guys, just hurriedly go and check it out. Just hurriedly go and check it out, the integral of sec x, because it's so common in the exam as well. It's so common. So just go and check this guy in my previous video. So guys, to integrate sec x, as you guys also, we still have to do a separate integration for that. Okay, that's going to be cumbersome. So it will be so easy if we can choose sec x to differentiate and integrate sec squared x, because if we integrate sec squared x, we are going to have what? Great, we are going to have tangents. Good. So now guys, we are going to differentiate sec x and integrate sec squared of x dx. Good. So guys, if we differentiate sec x, we are still going to have sec x tangent of x dx. Good. So that's what we have. So we have sec x tan x. Then if we integrate sec square x now, good, it brings us back to tan x. Good. That's great. So guys, now the integral of sec cube x dx, which is the same like our I now turns out to be now we are going to multiply these two diagonals, multiply this diagonal and this one to get the first part of the answer. So we are going to multiply these two diagonals to have sec x tangent of x. Then now we multiply by these two rows, now by this row here, and still put it inside of the integral. So I'm now going to have minus the integral of sec x tangent of squared x dx. Good. So this is what we have, guys. Like I said, this is the summary of the integrations by part method. This is just the DI method, just comes in to summarize everything. So guys, now in this case, now we are just simply going to have I to be the same, like, because our I is the same like the integral of sec cube x, right? I to be the same like the integral of sec cube x dx, which is the same like sec x tangent of x minus, this is the first part of the answer, then minus sec x tan squared of x dx, guys. But keep in mind that tan squared is the same like what? Sec squared x minus 1. Good. So now don't forget that tan squared x is the same like sec squared x minus 1. So if we substitute what we have into this expression now, guys, we are simply going to have now the integral of sec cube x to be the same like sec x tan x minus this sec x, we have it here. Then tan squared x, we know that to be what? Sec squared x minus 1. So we simply plug it in. Then now if we multiply all the brackets together, we are simply going to have the integral of sec cube x dx equal to sec x tan x minus, multiplying the brackets and splitting the integrals, we are going to have minus the integral of sec x times sec squared gives us sec cube x, then minus gives us plus, then we have plus the integral of sec x dx. Good. So guys, what do you notice? What do you notice, guys? What do you notice? Just pause the video and look at what you've noticed, then unpause it to check the right solution. Okay guys, hopefully you've paused the video already, right? Good. So now you notice that we have the integral of sec cube x on the left hand side, right? Then here is still what? Minus the integral of sec cube x. So this is the same like this, not so. Good. So in such a case now, we are simply going to carry what we have here to the left hand side, because we simply add the integral of sec cube x on both sides. So if we carry it this way now, it becomes the integral of sec cube x dx plus the integral of sec cube x dx, which is obviously going to give us 2 of what? It's simply going to give us 2 of them, right? Because we have 1 here, we have 1 here, so it gives us 2 of the integral of sec cube x dx equal to sec x tangent of x plus integral of sec x tan x. Guys, what do you discover? In my previous video, we saw the integral of sec x dx, right? So please, if you haven't watch it, just hurriedly subscribe to the channel so that you have access to watch it, guys. Thank you very much. Okay, now in this case, now we know that we have 2 integral of sec cube x dx equal to sec x tan x plus the integral of sec x dx, as we saw, was given as natural log of the absolute value of sec x plus tangent of x in the absolute value. But we know that we have to integrate sec cube x dx, right? Not 2 sec cube x dx. We are going to isolate the 2 by multiplying all by 1/2 or dividing by 2. So if we do that, we are simply going to have our answer coming out, where we are going to have the integral of sec cube x dx equal to 1/2 sec x tan x plus 1/2 natural log of the absolute value of sec x plus tan x plus c. So guys, this is the answer to our problem. This is the answer to our problem. So thank you very much, guys, for watching the video. Thank you so much for all your support. Thank you for subscribing to the channel, and please don't forget to like this video. Don't forget to like it, guys. Just make it as a habit that each time you watch our content, you must like it. Thank you very much indeed. And put your comments, just place your worries in the comment section if you have any difficulties, and I'm going to reply to them as early as possible. I'll reply to them before you notice it. Yeah, even if you understood, you just put your comment. If you didn't understand, put your comment. To you that has understood, you just hear what I'm going to say. To you that did not understand, I'm going to explain it further in a manner that you will understand. Thank you very much for watching, and have a great and blessed day.